Hi everyone. Have you ever heard of the concept microgrid? Today you will learn its definition and the advantages that microgrids can bring to the power system of the future. You will also learn the concepts demand side management and demand response. Let's recall the main changes that are likely to occur in the power system. First, generation will consist more and more of small scale, uncontrollable renewable sources. Most generation and consumers devices will likely work with direct current. Generation is likely to occur at the place of consumption, and storage would play a major role in the power balance of the system. Finally, smart grid concepts will operate when allowed. Before we move on to the definition of a microgrid and its role in the power system of the future, let's quickly go through some important concepts such as direct current, alternating current, active power, and reactive power. Direct current, abbreviated as DC, can be defined as an electric current that flows only in one direction. Alternating current, abbreviated as AC, is defined as a periodic electric current that reverses direction. It can have different shapes. In traditional power system, it has a sinusoidal shape. Active power is the usable power. It is the portion of power that produces a net transfer of energy in one direction every cycle. The load is able to use this power to do work. In DC, the power supplied by the load is the same power that is transferred towards the load when no losses are assumed. In AC, this is just a portion of the total power per cycle. In contrast, reactive power is the portion of power that returns to the source in each cycle and therefore cannot be used by the load to do the work. Reactive power is considered in AC systems. In this course, we will not deal with reactive power, but it is important to mention that the efficiency of the system increases as the reactive power flow decreases. The distribution system of the power system has traditionally been passive, but this is changing rapidly. The distribution system is evolving into an active network. Through the participation of distributed generation and storage, and through the application of demand side management. According to the Euroelectric Association, the aim of demand side management is to reduce energy consumption and improve overall electricity usage efficiency through the implementation of policies and methods that control electricity demand. One of these methods is demand response. According to the Euroelectric, demand response makes use of incentive payments designed to induce lower electricity use at times of high wholesale market prices or when system reliability is jeopardized. Two main differences between a passive and an active distribution network is that the power flows are bidirectional and that the decision-making processes and control mechanisms are now distributed, occurring at the low voltage level in contrast to passive distribution networks, in which there is no distribution generation and loads are uncontrollable. Microgrids emerged as a response to the need for active distribution networks. Microgrids are regarded by many as the building blocks of the smart grid, particularly when referring to low voltage levels. The official definition of a microgrid, as given by the SIGRE working group, is the following: electricity distribution systems containing loads and distributed energy resources that can be operated in a controlled, coordinated way either while connected to the main power network or while islanded. If we analyze this definition, we can identify three main characteristics. First, the microgrid can be considered an integrated platform for distributed generators, storage devices, and controllable loads at distribution level. Second, control and coordination at the distribution level means that there is an active operation of the distribution grid. In contrast to a passive distribution grid penetrated by distributed sources, but where no control or coordination is implemented, a microgrid allows to manage and coordinate the available sources and the controllable loads. This allows the power balance between generation and consumption. Third, Microgrids have two modes of operation: grid-connected and islanded mode. The second operation mode can be also called off-grid or autonomous mode. This mode of operation allows microgrid to work even when there is a failure in the main grid. Microgrids have the potential to provide several advantages to the power system. For example, they can ease the integration of distributed generation, demand-side management, and storage. They will encourage the creation of new business opportunities for electricity trade. In terms of operation, they can provide the standalone operation and have the potential to aid the network by providing ancillary services. For example, by participating in the power balance of the network, other ancillary services could be relieving congestion from the lines and aiding restoration after faults occur. Finally, as microgrids can operate in a landed mode, they are very suitable to be applied in developing countries, particularly in places where there is no electricity infrastructure. In this lecture, you got familiar with the microgrid and its advantages. Could you think of its challenges when operating in a landed mode?